So the topic for today's lesson is optimization. Now I want you to recall the basic idea of optimization from your calculus 1. So when we say optimization, optimize something, optimize a function, so it may, mean sometimes maximum, sometimes minimum, depending on the situation, depending on the context. Okay, for example, if you are given a profit function, okay, profit function, then optimization means you want to maximize. And if you are given a cost function, for example, so if you want to optimize your cost, it means you don't want to maximize, you want to minimize cost. Okay, so depending on the context and situation, optimization has different meanings, sometimes maximum, sometimes minimum. Keep that in mind. Okay, all right. Now, before we jump into how to find the maxima and minima, relative maxima and minima for function of two or more variables, I want to take you to calculus 1 just for 1 minute, if you don't mind. Okay, let us quickly review calculus 1. In calculus 1, let's say you are given a function. F of x is, let's say, x square minus 2x, for example. Then to find the maxima or minima, what you do is you first find the derivative, first order derivative, which gives you 2x minus 2. And then you also find the second derivative, which gives you 2. And then you find the critical number. This is your step 1. Find the first and second order derivative. Well, yeah. Now in step 2, you may want to find the critical number, right? Step 2, you find the critical number, which means f prime of x equal to 0. This gives me 2x minus 2 equal to 0, which is x equals to 1. This is your critical number. Now in step 3, you do the second derivative test or first derivative test. Second derivative test. In this case, what you're going to do is you just find the second derivative, which we already found, which is 2. And since the second derivative is positive, so the graph is concave up, right? The graph is concave up. Remember, the second derivative gives us the concavity of the graph. So it's concave up, which means the shape is like this. So we'll have minimum value at that point. So these are the 3-step methods that you use to find the maxima and minima. Anyway, and there is another method for this second derivative test. You can use the first derivative test as well if you like, which means you need to draw the number line, put the critical number here, and then you test the point, right? You test this point and any random point in that interval, but that is little time consuming. So we use second derivative test if possible. Sometimes the second derivative test actually fails. In that case, you use first derivative. Okay. What it means is if you draw a graph of this function, the graph looks like this, and at x equals 1, you'll have the minimum here at x equals 1. When x equals 1, your y value will be negative. Okay, this is 1 minus 2. So that's negative 1 is your y value. So that's the minimum point, right? That's how we find. And let us look at the local minimum and maximum in 3 dimensions. So if we draw the graph of 3 dimensions, you will get a surface. Okay, like this. This is the graph of a function in 3 dimensions, z equals f of xy. So maximum means there is one maximum there and there is another maximum there. We call them local or relative maximum. But out of these two, this one is the real maximum and we call it absolute maximum. Okay, so in this neighborhood, this one is maximum. In this neighborhood, this one is maximum. If you look at the globally overall graph, then this is the real maximum, therefore we call it absolute maximum, but this will simply a local maximum. In the same manner, there are two minimum values. One is this and another is this. So in this neighborhood, in this locality, this is minimum, and in this locality this is minimum. Okay, so both are actually local minimum, but this one is absolute minimum because this one is the real minimum globally in that overall graph. So we know the meaning of local and absolute in calculus 1 as well. Same idea, but only the difference here is that the graph is different here, because now the graph is a surface, whereas when we talk about 2 dimension, the graph is simply a function like this, right? Just a line, a curve. Now, what it means is a function f of x has a local maximum at ab if f of ab is greater than or equal to f of xy. So this one, if you look at every single point near that neighborhood, so this one is the real maximum in that neighborhood. Therefore, you see FAB is actually greater than all the other points in that neighborhood. So we call it local maximum. The same definition can be given for local minimum, which means we have one point here. As you can see, this point is minimum. That means this point is less than every other point around that neighborhood, every other point around that neighborhood. Therefore, this one is called the local minimum. Okay. Now, here is the technique that we're going to use to find local minimum and local maximum. Step 1, it is very similar. Look at that. What we did in calculus 1 is step 1, we find the first derivative and second order derivative, right? We do the same thing here. We find the first and second order derivative. That's step 1. Step 2, what did you do? Well, you found the critical number. And we do the same thing here. We solve the system of equation to find the critical points. Step 3, what did you do? In calculus 1, second derivative test. We do the same thing, but I call this second derivative test in case of function of 2 variable, I call it D test. Okay, it's pretty similar to the second derivative test in calculus 1 for function of 1 variable. You need to remember this formula. Okay, D equals second partial derivative of f times second partial derivative with respect to y minus f partial derivative of with respect to x and y squared. So this is the formula that we'll be using. And if D is positive, then two things can happen. Either the second derivative with respect to x is positive, or the second derivative with respect to f with respect to x is negative. Okay, second partial derivative with respect to x is positive or negative. Depending on that, we'll figure out which one is maximum and which one is minimum. If D is negative, then we call it saddle point. And if D equals to 0, then we say that the test is inconclusive. Okay, so that means we cannot determine whether that point is maximum or minimum. Now, let's look at, let us talk about saddle point. What is the saddle point? The saddle point is something like this. Look at this point in the graph. If you look at from this perspective, okay, if you look at this point from that perspective, This is the bottom of the parabola, which means it is minimum, right? It is minimum. But if you look at the same graph from that perspective, this is the top of the parabola. Okay, so depending on the what perspective you take, it is sometimes minimum, sometimes maximum. So that kind of point is called the saddle point. Okay, so that happens when this D test, when the D is less than 0, so then we'll get that kind of point. We call it saddle point. Now, too much talking. Let's work example 1. I will do one of these two, A or B. Choose which one you want me to do, and then the remaining you have to do yourself. Tell me, guys, tell me which one you want me to do here. Okay, let's try part B. Let me just copy the function, okay? The function is fxy equals xy minus x cubed minus y squared. All right. Step 1, find the first and second derivative. Step 1, find first and second derivative. So you guys already know how to find the first and second order partial derivative. So let us find f sub x, which means to find the derivative, we consider x as our variable and y as a constant. We treat y as a constant. So therefore, you will get y is constant. Let me just copy that down. And derivative of x with respect to x is 1 minus derivative of x cubed is 3x squared minus this one derivative with respect to x is 0. So that's going to give me a y minus 3x squared. Okay. And let us calculate f sub y. So for y, we treat x as constant. So x is constant. I just copy that down, and derivative of y is 1 minus x is constant with respect to y. So that's going to be 0 minus 2y. So I can write that to be x minus 2y. Now let us find the second order partial derivative. So second order partial derivative means we have f sub x right there. So we need to find the derivative of this one with respect to x. Okay, in another word, we need to find derivative of this one with respect to x. All right, which gives me with respect to x, so this guy will be 0 minus 6x. So I can simply write 6x there. Minus 6x, okay, this is negative. And let us calculate second order partial derivative with respect to y. So that's going to give me, it means derivative of with respect to y, this guy, x minus 2y. So that's going to give me derivative of x with respect to y is 0 minus 2. So you can simply write negative 2. In the same way, you can find f sub xy. Notice that f sub xy is f sub yx. They are equal. So we just find either this or this one. Okay. So let me find this. What it means is we have f sub x, which is f sub x is y minus 3x squared, y minus 3x squared, and we want to differentiate that function with respect to y. So we're gonna get, 1 minus 0, it's simply 1. Okay, so we got all of these first order and second order derivatives. Step 1 is done. Step 2, to find critical number, set first order derivative 0. We know that, right? First derivative equal to 0 gives us the critical, I'll write critical points instead of number. Critical points. Set this one. So f sub x equal to 0, so that means y minus 3x squared equal to 0. Remember that f sub x is right there. And f sub y equal to 0, which means x minus 2y equal to 0. All you need to do is solve this two equation. Okay, this is, let's say, equation 1, this is equation 2. We just need to solve. And you already know how to solve these equations from your high school. And one of the easiest method would be, maybe I'll write y equals 3x squared, okay? And I'll substitute that value there. I'll get x minus 2, y means 3x squared equal to 0. So I'm going to get x minus 6x squared equal to 0. So that's going to give me x common. So I'll get x minus 6x, 1 minus 6x equal to 0. So this is going to give me x equal to 0, or 1 minus 6x equal to 0. So this gives me x equals to 1 over 6. So we got two values, okay? Let me just write it down. So we have, x equals 0 and 1 over 6. Now, when we say point, we are trying to find a coordinate x and y, okay? We want to find the coordinate xy. So let us find coordinate xy. So when x equals to 0, your y value, how do we find that? Well, substitute the value. Here we already know the y. So y equals 3x squared, which means 3 0 squared gives you 0. So the one point is 0, 0. And when x equals to 1 over 6, you can substitute the value either in equation 1 or equation 2, whichever is easy for you. So when x equals to 1 over 6, so you can actually substitute here. Y is 3, x means 1 over 6 squared, which gives me 3 times 1 over 36. So that's going to give me 1 over 12. So another point is 1 over 6 and 1 over 12. So the critical point are, therefore, critical points are 1, 0, 0 and 1 over 6, 1 over 12. So we got the two critical points. Now recall from calculus 1, critical point is the candidate for maxima and minima. And in our case, it is the candidate for maxima, minima, or saddle point. Let's test whether it is a minimum, maximum, or saddle point. Okay, step 3. For step 3, d-test. Remember in step 3 what we did earlier is, recall that step 3 is second derivative test. Let us do that. I call it d-test, guys. For second derivative test, I call it d-test, which is d equals, the formula is partial derivative, second order partial derivative with respect to x, which is f sub xx times f sub yy minus f sub xy squared. That is the formula. So let me substitute the value. F sub xx is, what is that? Negative 6x. Okay, I'm just substituting the value. You see here, f sub xx is negative 6x, and f sub yy is negative 2, and minus, it is negative 2 minus f sub xy, which is right there. This is 1. Okay, negative minus 1 square. That's going to give me 12x minus 1. right? Okay, we got positive 12x minus 1. Okay, that is our d. Now we need to test this d for both the points. So now for critical point 0, 0, your d equals 12 times x is 0 minus 1, which is negative 1, which is negative. So now if d is negative, what happens? Let's look at the method here. If d is negative, so when d is negative, what happens? Then f has a saddle point at the critical point. Okay, so that point is a saddle point. Okay, it's negative. So 0, 0 is a saddle point. Any questions so far? Now let's test for another critical point, which is 1 over 6 and 1 over 12. So what happens? D equals 12 times x is 1 over 6 minus 1, which is going to give me 1, which is positive. So if D is positive, then what happens? Let's look at that. Let me take you all the way up there. If D is positive, then two things can happen. The second derivative is positive or negative. If it is positive, then we'll have minimum. If it is negative, we'll have maximum. So let's check that. Second derivative is d is positive, and your f sub xx, which is negative 6x, which means negative 6x is 1 over 6. So that's going to give you negative 1, which is negative, right? So when the second derivative is negative, you're going to get concave down. Okay, so it is concave down. When it is concave down, the shape of the graph is like this, so we'll have maximum. Therefore this one is maximum. Okay, let us write that. Hence the function f has maximum at 1 over 6 and 1 over 12, and the maximum value is given by, you put this value in the original function. So the original function is, so let me look at the original function. What is that? xy, which is x means 1 over 6 times y is 1 over 12 xy minus x cube. So x cube means 1 over 6 cube minus y square, which is 1 over 12 square. And I want you to simplify this and let me know what do you get. My calculator is telling me that it will be 1 over 432, but I want you to verify this answer. Okay, so this function has maximum at this point, and the maximum value is 1 over 432. Any question? All right, guys, if you don't have any questions in this, then let us try part C just for fun. And let me just copy what is there, what is given in part C. In part C, we are given a function xy equals x power 4 plus y power 4. I trust that you can follow this step and do it by yourself. Okay, but if you need help, I'm gonna do it here and have a look. But the first thing you may want to try is just try without looking here. All right, so now step 1. We find f sub x f sub y, f sub xx, f sub yy, and f sub xy. So these are the things we're going to find first, step 1. So this one will be 4x cubed, and partial derivative with respect to y will be 4y cubed. Partial derivative with respect to x, again the second partial derivative will be 12x squared, and this one is going to be 12y squared, and so f sub xy is going to be 0. Okay, that's what we got. Step 2. So to find the critical number for critical points, you set f sub x equal to 0 and f sub y equal to 0. So that's going to give you 4x cubed equal to 0, and this will be 4y cubed equal to 0. And so from here you'll get 0, x equal to 0. From here you get y equal to 0. Okay, so what we got here is that our critical point is, the only critical point is 0 and 0. Step 3. Let's do the d-test. For d-test, you need to memorize the formula, which is f sub xx times f sub yy minus f sub xy squared. The proof of this is sometimes called discriminant, okay? This d is sometimes called discriminant. All right, so the proof of this formula is not required for this course. All right, so let us substitute the value. So then d is f sub xx is 12x squared times 12y squared minus 0 squared, and that's going to give you 144 x squared and y squared. So for at 0, 0, your d equals 0, right? D equals 0. Then when d equal to 0, then what happens? Let's go back to here. So if d is 0, then the test is inconclusive. So there could be a local maximum, local minimum, or there could be nothing like maxima and minima. We don't know. Basically, the test fails. Now, why this test failed? Well, let me draw the graph of these functions, okay? And we will see if the test fails. Another method to check whether we'll have minimum or maximum is to draw the graph, okay? Let us draw the graph. The test, I just write the test failed. Now, let us look at the graph, okay? So graph of let's see what kind of graph do we get. Just give me 1 second. Okay, so because our d-test was inconclusive, it failed, we want to look at the function graphically. Let me type in the function here. Our function was x raised to power 4 plus y raised to power 4. Such a nice graph. Look at that. This is the graph of z equals, or f of x, y equals x power 4 plus y power 4. Now, notice that there is a 0, 0, which should be the minimum in this case. Okay, can you see that? It should be the minimum, right? But the reason is that our test actually did not give us the concrete result is because, let me go back to my previous slide. Okay, I just copy and paste the graph here. Can you see that? Now, the thing is, it should have local minimum there at 0, 0, but because it's flat, the bottom of this ball, it's flat. So that minimum point is actually invisible. And that's why the test actually failed. Okay, even though it has minimum at that point in that neighborhood, all the way on the bottom, but the bottom is flat. So this one point looks like it's invisible there. Okay. And with this, I want you to try part A yourself later, but let us quickly use this concept to solve real world problems, this example 2, and then you'll try this part A from example 1 on your own. Let's try example 2 together quickly. Okay, just give me 1 second. Example 2, a firm produces two kinds of golf balls, one that sells for $3 and one priced at $2. The total revenue in thousands of dollars from the sale of X thousand balls at $3 each and Y thousand balls at $2 each is given by, oh, revenue function is given. Okay, what is given is the revenue function is given to be 3x plus 2y, and the company determines that the total cost in thousands of dollars, pay attention to the unit, okay, thousands of dollars, of producing X thousand of the $3 ball and Y thousand of $2 ball is given by, cost function is also given, which is 2x square minus 2xy plus y square minus 9x plus 6y plus 7. All right. Now, what we want to do, how many balls of each type must be produced and sold in order to maximize profit? Okay, we need to find what value of X and Y will maximize the profit. Remember, our objective, our goal is to maximize profit. Okay, and also find the maximum profit. Okay, let's try that. In order to maximize the profit, first of all, we need to know what is the profit function. Okay, so profit function is, we know that revenue minus cost, right? Which means revenue is 3x plus, I can also write this as R of xy minus C of xy, revenue minus cost, which means 3x plus 2y minus 2x square minus minus plus 2xy minus y square plus 9x minus 6y minus 7. Okay, now if you simplify, can we do any simplification here? 2y and 6y, you can combine them together. So combine the like terms and what do you get? So your profit function P of xy is going to be okay, 2x squared, there is no other 2x squared. I'm going to write negative 2x squared and plus 2xy plus y, not plus, minus y square, and plus 12x minus 4y minus 7. Okay, if you combine the like terms, then that's what your profit function is. And once you have the function, you follow the three-step method. So step 1, you find this partial with respect to x and partial with respect to y. Let us find that, which is negative 4x plus 2y plus 12. And let us find partial derivative with respect to y, partial of p with respect to y, which will be 2x minus 2y minus 4, right? And now let us find partial with respect to x and again x. So second order partial derivative with respect to x, and that's going to give me negative 4, and this p sub yy is negative 2, and p sub xy is 2. I trust that everybody know how to find this first order and second order partial derivative. Now, step 2, we need to find the critical number. For critical points, what you need to do is set the first order partial derivative equal to 0. Guys, I want you to complete this by yourself. I think you can do it, okay? I trust you guys. Okay, solve this two equation. You already know how to solve this linear equations from your high school. Solve it and let me know what is the value of x and y. Type your answer in the chat box. All right, guys, pretty much everyone got the answer to be x equals 4 and y equals 2. I trust you guys because it's very difficult to get the same wrong answer. Everybody got this one in the chat box. I can see that. So yeah, therefore the critical point is, therefore critical point is 4 and 2. Now step 3, I want you to try d-test. D means discriminant, okay? D-test. In D-test, write down the formula. So D is positive. And now the second derivative. Oh, guys, this one is not F. This should be P. Okay, we're talking about the function is P, profit function. Let me just change that F into P. So the second derivative P sub XX is, we already know, negative 4. Now, D is positive, but the second derivative is negative, which means it's concave down. So concave down, when concave down, the shape of the graph will be like this, so it has maximum. When the second order partial derivative is negative, so we'll have maximum. So maximum means we're talking about local here, okay? Local maximum or relative maximum. Okay, therefore, the final answer is maximum value of pxy occurs at 4 and 2, and the maximum value is you substitute this value in the original function, and the original function is here. Let's say this is equation A, or maybe, yeah. So that equation is negative 2x means 4 square plus 2x is 4 and y is 2 minus y square is 2 square plus 12 times 4 minus 4 times 2 minus 7 equals, okay, how much is that? I got 13. I want to check that with you guys. Okay. All right. So mathematically, we are done. Because this question is actually a real world application, then we need to answer this in a nice way. Okay. So nice way is 4 means x. X is 3 type ball. So that means the answer will be so the company should produce and sell 4, the unit is 1000, so 4000 balls of $3 type and 2000 ball of $2 type to maximize profit. Okay, and the maximum in that situation, what is the maximum profit? And the maximum profit is $13,000. Okay, any questions so far? So if there is no questions, then this lesson is done. So in our next lesson, we will look into Lagrange multiplier. We'll talk about Lagrange multiplier in detail in our next class, okay?